Alright lads, so we've got 2017 short questions. So question 1, you can see here you have, I've already filled them in, so you have a sector. A sector means any part of the circle, so there's two ways to divide up a circle. One is by, like you do an apple tart, one is by joining a point from the circumference into the middle and back out, so it's like a slice of the circle. The other one is a segment where you just make a chord and that divides the circle into two. So that's what a segment is. Okay. Then when you've types of circles, so a concentric one is, what do you think the difference between a concentric and eccentric would be? Well, a concentric, they both have the same centre. Alright, so you can draw a million concentric circles, they'll be getting bigger and bigger, but they all will have the same centre, whereas an eccentric one, they do not have the same centre. So concentric, like a dartboard, say you have the bowl and the ring around the bowl, and then you have your trebles, or if you're familiar with that. So they're all concentric circles inside that. Alright, so next one is the perspective question. So you can see I have a bit of it done here already. So the figure shows the incomplete perspective drawing of an ice hockey table. A 3D graphic is also shown. Complete the perspective drawing. So remember what I said before, lads. So you have lines kind of going in different directions, and what you have to remember is that the lines, if they're going parallel to the ground, so if the lines are travelling parallel to the ground, then in perspective they're going to hit a vanishing point. Alright, so you can see here the inside of that, their lines, and even though they're going at angles, in real life they're going to be travelling parallel to the ground. So you can make out what vanishing point they're going to hit. They're going to go towards there. So you have the corner there, you have to draw that. That's a line parallel to the ground, you have to draw that back to that vanishing point and fill in H what you need. Similarly here, the line is going in a different direction but still going out to the vanishing point. So you draw that out to the vanishing point, and that'll cut off them two lines, and you'll be able to see the inside or the top of that ice hockey table. Alright, now the other thing, when we get down to doing this inside part, you can see here there's a diagonal done on the question. You can see two diagonal lines drawn, and that's obviously giving me something. And if you look closely at it, which caught a few people when they were doing it, that line where the point where it crosses over actually gives you the height of that underside. So if we do it, if we cross over them two lines, there we go. So we cross over the two lines, and that gives us there the height of that inside part. Alright, now that inside part, what's the story with that line? Well, it's a line travelling parallel to the ground, and you can guess what vanishing point it's going to. It's going to go out to this one. So I have a point on it. So what do I need to draw a line? I need 2 points. I have the vanishing point and I have the point. So I draw that, and that'll give me that line. I've drawn 2H there like that, and then I'll fill it in H. So that line goes vertical. Vertical lines stay vertical. So that's going straight up onto that line, as is this one out here. And that gives me the underside of that fella there. There you go. Alright. Okay. And then this line going back here, it not only is it a line parallel to the ground, it's actually on the ground. So there it is there. It follows the same rules. If it's going that direction, it's going out to vanishing point 2. So I'll join it up to there. And draw it out like that. And then I'll fill in what can I see. It goes all the way under until that lip over there covers it. Alright. Then just to finish off this side, what's the story with that? That's a line travelling parallel to the ground. Just there like that. And it's on the ground as well, it's going out in that direction. Now, this one here, we're going to have to do something different with that, because as you can see, this line going up here is not a line travelling parallel to the ground. So what is the story there? Well, we can see what they did on the front here to get it. If you join that corner straight down till it hits the ground, and travel straight in along the ground there like that, out to the other vanishing point, where it crosses this line here, we'll get you it. So we'll do the same over here. There's my line going straight down till it hits the ground, and then I'll join it out to the other vanishing point. And that point there is where it hits that base part. Alright? So that's tricky enough there now. There we go. There we go. So we'll finish it there. There we go. Alright? So that finishes off that question. Right, grand. Next one. Okay. Next one is figuring out angles and things. Right, so the figure shows the outline of a logo for a locksmith. Write down the measurements of A, B and C. Okay, so A is actually given to us. So A is going to be 20, isn't it? So the length of that is 20. It's actually given in the drawing. Alright, money for jam. Right, so then you can see inside it, it's clear what's going on inside there. If we drew it in, you don't have to do this now, but if you drew it inside, what is it? It's a hexagon inside a circle. Alright, now if you know the construction of that and what the story of that is, you'll solve this quick enough. So we know from a hexagon, the external angle of a hexagon is, if I didn't know, there's 6 sides in a hexagon. 360 divided by 60 is 60. That's 60. So the rest of that 180 angle is going to be 120 degrees. Okay. Now the other thing you need to know to get C is, sorry, no. So we have. So you need to know that inside in a hexagon are 6 hexagons, or sorry, 6 equilateral triangles. Equilateral, 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 right? So that would mean that if that's 20, then that's 20, then that's 20, that's 20, they're all 20s inside it. Okay? So if all of them are 20, and the distance from here up to here is the same as that, that's the same as this distance here. So if they're all 20s, that means that distance there is 20. Alright? Alright, so if that's 20, we have 20 there. Tells us here that the radius of the circle is 15. So the distance from there to there is 15. And if it's a circle, the distance from there to there is 15. The diameter is 30. The radius of this is 20. So we can see 15 plus 15 plus 20 gives me 50. Alright, so that's the question done. Okay. That's for that. Alright, question 4 is a sketching question. Just stick this for now. Alright, so this is on here, right, grand. So, sketching question, guys, you should be getting a little better at these now. So, you can see how they're starting out. The elevation and end view of the keyboard are shown on the square grid. Make a freehand pictorial sketch of the keyboard, colour or shade the sketch. Important, lads. Money for jam there now. Right, so, they've obviously given us this base piece here. You can see it's kind of a truncated triangle, or triangle, yeah, so it's kind of a truncated triangle, right? Okay, so we have, so we've got the side going in, we've got, you can see here this angle going back. Obviously we can't use protractors in this question, so you can see it goes in 1, 2 and up 1. So it's gone in 1, 2 and up 1. So I must do the same from the other side because it's symmetrical there. So 1, 2, up 1. There it is there. Alright. How high does that leg go up? 1, 2, 3, 4. Alright, so we go up 1, 2, 3, 4. Alright. Okay, so that starts off that leg for us. Now I'm doing all this in 2H, who knows what happens from here. Right, after that it widens out, so it goes out 1, 2, so now 1, 2 here, 1, 2 the other side. Alright, so that's there. Up, we'll put the keys in the front here. So from that 1, 2 goes up 1, and from here it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Okay, there's that there. How far in does it go? 1, 2, 1, 2 to the front of this. The front there. That flip back there like that. That gives us that kind of lip in the front. After that, then it goes up 1 and in 1. So in 1, up 1. There's the angle there. And then it goes all the way back to the back, which should be 1, 2, and there it is, 1, 2. Alright, draw it up on that there, on that there. So we do the same with this one. It goes in 1, up 1. There's the angle there, and then it's going back 2 like that. So it should meet that line going back. After that, you can start the leg from the inside here, but it's probably just as easy to count. It should be 7. 1, 2, 3, 4, 5, 6, 7. So it is 7. 1, 2, 3, 4, 5, 6, 7. So the next leg starts there. So that's the front of this, and it's going to be the exact same as that. So you can see, look, in 2, up 1, in 2, up 1. There's my leg there. I can just repeat it here beside it. Alright, in the thread there. The base is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's that there. And then in 1, 2, and up 1. So there's my ankle in there. And that leg goes up till it disappears in underneath. Alright, so that's the basics over there. So I've got all done 2H. And draw it, and missing a little bit here, just back of the leg here. Have to go all the way up to this line here and disappear behind it. Okay, so just fill in what I need. So you're doing this with your H pencil. Remember, trying to avoid them hairy lines, lads. Just one sweeping line if you can. If you do it a second time, do it a second time. Okay. Down, down. Be happy enough with that. Alright, we do a bit of, we'll shade it. Alright, so remember, sun is going to be up here. What's going to get the sun, what's not. So this side is not going to get the sun, so we'll go heavier on that side. So you do a better job than I will, but try and make sure just the colour is even, there's no gaps. That'll be the big thing for shading, if you want to get the full marks of this. So all that's going to get it. This inside here is not going to get any sun. Alright. Go heavy there. After that, so this is going to be the lightest. This is going to be the lightest because the sun is shining down top, but this will probably be slightly, not massively, won't be white, but it'll be slightly darker. This one here will be darker again. Not as dark as here. Might get a little bit of light here at the side, but something like that. Same on this side. Not as dark as this inside part here, but it will be dark enough. And then this fella will be slightly lighter again, I would say. Same here, darker but not as dark at the back. And then maybe lighter here. Same here, same here. Actually, you know what? I'm missing a little bit inside here, am I? In one, and then that goes up there. That over, give a little line in there in the back. After that, I'd say be happy enough with that. Let's be happy enough that you can do the black around the outline if, like I showed you before, but you should be fine with that. Alright, next one. So we're doing the figure shows the line of a lampshade. Draw a new shade similar to the given shade with the length ABC increased to AB1. Or sorry, AB increased to AB1. So look, we know what's anything where you see similar and it's enlarging, or you're trying to make it bigger. You're thinking that flashlight I was on about you before. So when you're trying to increase the size of this thing, so you can see here on my hand in the shadow, like that shadow is exactly the size of my fingers there. The more I move away from it, you can see they get bigger. Right, so that's what you're trying to think of when you're thinking about enlarging something. So the key to this is what point is going to stay the same. So what point is going to stay the same here? So if AB increases to AB1, What's the same? Well, it's A, isn't it? So that's where I'm going to stick this flashlight anyway and start shining it to make this thing bigger. So I'll start at A and I'll just start making things bigger. So there, get all the points on it. You can label them if you find it handier. Just make all the points. There's another point here. I'll make that bigger. There's another point there. I'll make that full of bigger. So I'm going to get everything shiny out of A. And I'll work from there. Right, so AB is going to be the same. AB just increases straight out so the line's going in that direction there. Now when it's similar, lads, we know this. When it's similar, the thing gets bigger, but all the angles stay the same. So if that's a vertical line going down there, well, it's a vertical line going down from B1. And where does it stop? Well, it stops where I've increased the size. So I've brought this point out to here. So if the angle is the same, it's going straight down there, it's hitting that, and it's going back here to this point here, which is enlarged out by that line. So there's my line there. Alright, there we go. Right, then after that we have this line is going down that direction. Remember, angles don't change, so I'm going to use the T-square here to get the angle. That angle is going up there at that. If it's going that angle in the original one, it's going that angle in the new one. So where is it increasing? That point goes down to there. So in the new one, that point goes down to where this will enlarge, which is out here like that. So there's a line got out there, excuse me. Then from there, that line goes straight across, so it goes straight across. It originally went to that point, that's where it enlarged to. I'll just draw that out there like that. It hits that line, and then I can go parallel to that line, or I can just join it back to the point. They should both be the same, and there is my new lampshade, you can see inside it. It's similar but bigger. Alright, after that, okay. So a bit of working out in this one, lads. So the figure shows a 3D graphic of a set of triangular flags. Grand. Each flag is an equilateral triangle. The length of each flag reduces in the ratio of 3:2:1. Figure 2 shows the incomplete elevation of the flags. Find the length of the side of each flag and complete the elevation. Right, so it's an equilateral triangle, which means all sides are the same. It tells us this one here is 3, 2, 1. It's smaller and smaller. So how do we figure it out? Well, this is 3 units here. That is, all them sides are equal to 3 units. So if there are 3 units, we'll figure out what's 1 unit. So to figure it out, we'll draw a line any length, any angle, off the edge of any of the sides. Like that. And we'll put 3 equal measurements along that fella. So we go 3, okay. So I'm going to go 3, that's 2, 1, 0. So there's 3 equal measurements. We'll join that back to the end of the line. So the last measurement back to the end of the line, join that to the end, slide it over, join that to the end, join that over to the end. Alright, so now that 3 is divided into 3 units. So now I've got 3 units, 2 units, 1 unit. So from that, I can start drawing my triangles. Now, if you want, you can go parallel to them, which are going to be at 60 degrees. But if you know the other way of constructing an equilateral triangle, well, you know, you can do the whole lot with a compass. So if I take, it's going to be 3, 2, 1. So if I take 2 on this, there's 2 units. And I'll mark off the base of the second one. There, like that. There's 2 units. So that's the base of the 2. And that distance is going to be 2. So I can mark the top of that triangle with the compass if I want. There we go. And there we go. So there's 2 units. That side is 2. Two, and the base is 2. And then to get 1, we do the same thing. Just take 1, length of 1 on the compass. Work it off here. There's 1. And then we do the same thing. Length to this side is going to be 1 unit. Length to this side is going to be 1 unit. Where the 2 of them meet is 1 unit each. And 1 for the base. So there we have. So there's our triangle question. Quick enough now, easy enough to draw. If you want to go parallel to the sides there, by the way, if you want to take that parallel and parallel, nothing wrong with that either. If you want to mark 2 and 1, I'll just show you the way with the compass. Alright? Okay, move on. Question 7. This is our auxiliary question. Okay. Right, so the figure shows an elevation and plan of a fuel bunker. A 3D graphic of the bunker is also shown. Project an auxiliary elevation of the bunker on the line x1, y1 to show the true shape of surface S. Alright, so we talked about this before, so what we would have done is to find the true shape in the last part of the orthographic projection question, we would have rotated this fella around so that he's parallel to xy and we can see him. But we've already discussed that instead of doing that, what I can do is actually change xy. So I'll keep this plan, but I'll change it instead so that I'm not looking in this direction. I'm going to look in this direction, straight at the line or the surface I'm looking for, and it'll give me a true shape of it up here. Alright? So nothing changes. Like even though I'm changing the view of it, none of the rules change. So if the lines are going up perpendicular to xy, then they're going up, when I change the view, they're going to be going perpendicular to x1, y1. Alright? The perpendicular lines, and I'll just start dragging everything up. So there's parallel to it, so that means the 90 degree angle is 90 degrees to it. Alright, so actually I'll go up a bit higher. Okay. So that bringing up all the points. And this fella here. Maybe a little bit dark there, but you need to be able to see it, so we're doing this in 2H. Okay, after that, what I do, well, I'll take a few height lines. So all the points are on either this height or the height on the top there. So I'll call this fella, I'll call him, what green pen I do? I'll call this fella H1, and I'll call that fella H2. And then we've got the ground as well. So I'm going to take up H1. So I'll take that distance. The vertical distance from the XY line to H1 is there. So I'll draw this below up here. Stop. Right. There's H1 and H2. Okay. Perfect. Right. So I'll put in right there's H1 and H2. Okay, grand. And what I'll do is I'll just draw a line straight across parallel to XY, and you know what, I can do everything from there. Which is actually at 30 degrees. So if you do pin down, you'll be able to just do it at X1, Y1 is actually at 30 degrees there. Alright. Okay. Right, so from there I should be able to get everything. So if I'm standing here looking in, this edge here is a line going from the ground up to H2. So I'll just draw that for line. So I'll draw in what I see in the front first. So I'll draw in all the surfaces. Then that goes along to here, this point here, it goes all the way up to here, along the ground. So you can see it there going along the ground. There it is there. So to this first line here, there's two very close together there. After that then, it goes up at an angle to this here at H1. So there it is there, it's that inside one. H1, there it is there. Alright, after that, goes from there back to this point here at H2. So there's surface S anyway. So one part of it done. Okay. Right, what else will I be able to see? Well, if I'm standing this, if that's me there looking at this, I'll be able to see this surface here. So it's kind of a quadrilateral here at the side. So I've got a line here going along the ground. There it is there on the inside. That's the lip on top there, this front one. Then I've got this line going along the ground. So it's this inside line here, beside this outside. So it's going from that point out to the outside line there. So I'll just draw that in there like that. Okay, to the outside line, grand. And then it goes from there up to the ground. It goes straight up here to that point, which on my drawing is here. And that height is at H1. And it's there. Perfect. Right, so that lip done in the front. We'll try and get this line here, so going back. So remember, line is the shortest distance from one point to another one. So where's the start point? Well, it's this point here, the end of it is over here. So I have that point there, and then this back point, where is it on my plan? There it is there. What height is it at? It's at H2. So there is the point it's joining back to, that inside, not the outside line, the inside line. So join it back to there. There's that line there. Like that, and then it's a line going all across H2 from this side to there, from there over to there. So that's from there over to there. So there's our drawing. We're missing anything? There we are. We're missing this. Look, that's there. Well, there's another one on the inside here, so we'll draw that. It's going from the height of H2 down to the ground. What's the problem? The problem is I can't see it, so I'll make sure I draw it. Like that at the line. I'll hit the line detail. Oh, there we go. Is that everything? I think that's everything. Right, sorted. And next question, the elevation and plan of a recycling bin are shown. In the space provided, draw freehand pictorial sketch of the bin, colour and shade. This is the completed sketch, right? Okay, so what you want to do here is you want to think about the body of it anyway. So look, I'm going to forget about the wheels for now, and I'm going to completely concentrate on getting the body of it done. Alright, so like I said to you before, first thing I concentrate on is getting the box it goes into drawn. So look, forget this angle here. I'm going to draw this box or cuboid that it goes into. And as I said to you before, get used to drawing these 30-degree sketch angles. So even if I want to give myself a guide, look, there's 30 degrees there. So that's the angles. 30 degrees that way, 30 degrees that way. So I'm going to need to get used to drawing at that angle. So it's going to be something like that. Draw my crow's foot at the start. There's something like 30 degrees to start. Right? 30 degrees, 30 degrees. I'll put the front of the bin facing this way. So it's going to be facing out this way. So I have to go back this distance in this direction. So there, I'd say something like that there. A little bit smaller. And then I'll draw straight up like that. Vertical line stay vertical. Okay, that's the height of it. That size. So I swung that around. It's not maybe. It's not double. It's less than double. So if I took that height and compared it to that, it's probably about there. So it's probably times and a half. So it's going to be that distance plus another half. So that distance up is about the same as that, about there. Plus half be about there, I'd say, something like that. Right? So here's the height. Okay, my proportion is this. If I took that down with a compass there, it won't be far off. It should be just under. If I took that distance there, probably that distance probably just over half of that. Put half there, put half there. That'll be half again, so it's just less than that. It's about there. I would reckon that size would be bad. Right? So parallel. These are all 2H lines there. Let's keep my 30-degree angles if I can at all. Alright, so there's the box that the body of the bin is going into. Now, as I know, it's not a box, it's going down at an angle, so it's going in this much. To get that angle there, I have to get in this distance here, of this over there. If I take that, put it on again, it's probably about a third. That, probably 1/3 the distance in. So I'd say, maybe there wouldn't be too bad. So I'm going to draw that in. So what? I'll do this in H. Alright, there we go. Okay, so here's my angle there, and I'll draw this fella going back 30 degrees, and I'll draw this fella. I can actually draw this one. Okay, so there's that front there. Okay, after that, we've got wheels here at the side. So how high? 1, 2, maybe going a quarter the way up. I'd call that maybe a quarter. So that's half the distance going up. That's half again. So that's going to be the height of the wheel there. Alright? So that's the height of the wheel. Find halfway along that to get the centre of the circle. Draw my 30-degree line. It's going to be that distance, same as that distance. It's going to be the same as that distance. It's going to be the same as that distance. So there's the inside of that wheel there. Draw a little circle, and I have to make that this thickness. So that's how we have to go the same distance out there. I'll draw that circle there like that. I'll fill that in. Okay, draw in that thickness. Right, not too bad there now. I'm going to draw in the rest of that what I can see. Okay, and after that we've got a lip. Before I draw that, it's still the same thickness, but there's a lip here that comes out, it sticks out that distance there, something like that. And then turns around like that. So that goes straight up there. 30 degrees. And get the top coming there. Right, so we're filling what we need. Like that. Right, so 30 degrees here out to that line. And then join that back there like that. Right, and then we can finish off this filler. So like that. Nothing down in the bad job. I won't do too bad there. Colour or shade to complete, so we'll do it in green wheel again. So we'll do the green, we might do the cover up to a different colour. So sun is up there, so that means this is going to be the darker side. Here like that. And go heavy with a colouring pencil, and if you want actually you go over it with a pencil after, it'll give you kind of a darker shade of that colour. Now let's see, a little bit of drop now, but try and get an even amount all around it. Do that there. Okay, after that, this bit here is going to be a little bit lighter, because the sun will probably be hitting that a small bit more. Like give it a small bit of shade as well. Small bit, not as much as the side. Now, as I said, you do a bit of drop level, but it's that there at front. So this, if we do the top of the bin, if we do the top of the bin and the wheels in the same colour, so we do orange. That's a typical way you'd see it then, but do there. Orange out here at this side. Now, and this bit around here is going to be orange as well. Look, that bit in there, obviously it's going to be dark here at front, and it's going to be even more dark underneath here, but look, the detail is so kind of fine here, you can't redo. But if you imagine that wheel, that inside there is going to be way darker, so just maybe add a little bit of darkness in there. And then same top, this side here is going to be dark, and we won't be seeing the sun at all. This one here a little bit lighter, and then this bit on top is going to be the lightest of all. Start that, and I might just add a little bit of shading to that, maybe a tiny bit to this, and we'll leave the top as it is. Right lads, there's our bin, not too bad at all. If you want, as I said to you before, you can do that, there's a black marker. Look, you can do an outline around the outside. But I always like to do it. If you imagine the flashlight in the back, I said that to you before, like a thick line out. You do with a black marker if you want. There it is, just to enhance it a small bit. That's great. Okay. After that, we've got our AutoCAD question. So write down any 3 CAD commands used to edit the drawing of the traffic lights as shown in the sequence below, alright? So, you remember what I said? So, the commands for drawing actual 2D shapes are straightforward enough, lads. They're named after the shape that you're drawing. So, what do you think that will be? Well, it's going to be a rectangle, isn't it? So that's rectangle. So look, we'll put it in here. Rectangle. Right, so if I draw 2D shapes, rectangle. Remember what I said? If you make the 2D shape like it's been squeezed out the front of a Play-Doh thing, a Play-Doh, one of them toys where you're squeezing the Play-Doh, it's all going out the same distance, same distance. So there's that shape at the side, same distance, same distance, same distance. That is called extrude. And if you round the top of something, if you round it in woodwork, if you made it at a 45-degree angle, that's called a chamfer. But if you're rounding it, if you're rounding the top of it, that's called a fillet. Like chicken, fillet, that's what it's called. So if you round the corner of something, you're putting a fillet on it. So if you're rounding the top of that, it's a fillet. After that, well, if you draw a circle on that, what do you think that's going to be called? It's a circle. So that's circle. And then after that, just double check. So there's 3 names for this. So if you're going to repeat something, same as what you do if you're doing Microsoft Word or something, you're copying it. Or if you're doing them all in the same direction, so circle, 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 so something like, if you ever see the holes on a speaker or something, they're all done with patterns. So if all the pattern, if they're all going in the same line, sometimes you see with a speaker, you'd have a circle, 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 circle all the way around, and they get bigger as you go along. They they go out from the centre, out along, so bigger circle, bigger circle. If they're all going in the same, so that's called a circular pattern, when they're all going around the circle. This one, when it's going in a line, is called a linear pattern. So linear pattern. Alright? And copy actually will do you there as well. So copy will do you there as well. Okay, that's 9. Alright. There we go. Stick on this fella. I'm going to use this line to line it up. Okay, right, so we start with the top one. Right, so the graphic shows the design of cyclist time trial helmet. The design includes an ellipse A and a tangent BC. Okay, the focal point of ellipse A and determine the point of contact between tangent BC and the ellipse. Show clearly all construction. So look, what they're saying here is that's a tangent. It's a tangent between an ellipse and a point outside the ellipse. Right, so if you think back to that construction, awkward enough construction now, that's one of the more awkward ones. So look, when you're thinking about tangents and ellipse, you'll need to get the focal points anyway. I think they actually ask you to do it here, do they? Yeah, locate the focal point. So you'll have to do it anyway. If you're talking about tangents and ellipse, you're going to have to think focal points. How do we get the focal point? Take the distance of half the major axis and swing it from the top of the minor axis. There and there. So I'll label them. I'll call this for the F1 and I'll call this for the F2. Right. Okay, so what you do is work backwards. The tangent is already there. So what they're basically saying is, if you were drawing, forget I have the tangent, what would I have done? If I had a point outside the ellipse and someone said draw a tangent to an ellipse from the point C, well, what would I have done? Well, it's one of the more awkward ones. You take the focal point furthest away from the point, and you swing an arc the size of the full major axis. The full major axis of the focal point furthest away, and swing an arc, like that. Alright? And then, the second thing you do, put the point of your compass on the point outside the ellipse, and take that over to the one closest to you, the focal point closest to you, and swing another arc from there. Like that. And when the two of them cross through, where the two of them points cross through each other, you join that back to the first focal point that you used. Awkward enough now, lads, and look, you just have to know it, so you'll have to do it a few more times. We've done it on the ellipses already, but where that crosses through the ellipse, that there is my point of contact, and I label it P-O-C. Locate the focal point C's and turn the point of contact between tangent B, C and the ellipse. There, done. How long will it take me? A minute. Probably take, if you knew that, it would take you a minute, so it's well worth knowing that sort of construction with. As opposed to, you're doing a sketching question which could take you 4 or 5 minutes. That's taking a minute if you know it. Alright? So well worth knowing. Okay, next one. Question 11. The figure shows the elevation of an adjustable set square. A 3D graphic is also shown. Rotate A, B, C, D and point about point O until point C reaches the line LL. So we've talked about this before. This is a rotations question. The object is rotating. If we're talking about rotations, what happens in transformation rotations? All points are rotated around the same point. Point of rotation, this particular question, point O. Rotate ABC all around point O. And what's the other rule? Well, how do they stop? They all go the same angle. They all rotate the same angle. What's the angle in this? They don't give it to us. They're saying the angle is when you take C, is it point C? When C hits that, that's the angle it's at rotating. And all of them rotate the same angle. So, look, I'll get all of them moving now. I haven't stopped them yet, but I'll get them all moving. So all the points are going to move around point O. So look, I'll just go to find my compass on point O. I'll rotate up C to give me C1 anyway. That'll get the ball rolling. Then I'll rotate D. Rotate D. Rotate B. And I'll rotate C. And I'll go more than what I need, 2H. Right, there we go. So, what point do I have? Well, I do have point. I have point C1 in here, so I can start with there. There's C1. So where C rotates up to hit the line L1, that's C1. Okay, after that, so we don't have to go through the hassle of figuring out that angle. What we can do is say, well, I know B1 is going to be on this somewhere. And I know the distance from C to B is going to be the same from C1 to B1. So I'll take the distance on my compass. C to B is that. So C1 to B1 is going to be that. So there's B1. Distance from A to B is that. So the distance from B1 to A1 is that. There it is there crossing through. So there's A1 there. Okay. And then the distance from A to D is that. So the distance from A1 to D1 is going to be from that point there to the rotation of D. Do you know what, we might do it from another point because it's very similar there. So I'll go look the distance from the distance from B to D is there. B to D is there. So the distance from B1 to D1. B1 to D1. There. B1 to D1 is there. Yeah, so look, you can see it's a good bit off. When you're trying to rotate the same, it's not ideal. Okay. So there's A1 to B1. There's B1 to C1. There's C to D1. and then there's D1 back to there. Right, so there we have our adjustable set square level at D1. So there we have our adjustable set square rotated. Alright, next one. The graphic below shows 3 puzzles. The solution to each puzzle is shown on the right. Match the correct letter with the appropriate puzzle below. Alright, so it's obviously this shape, they're just turned around. So we'll have to have a look here. Right, so big difference between the two of these is that distance there. If you look at that distance, the only one, I've got 2 here with that distance. So we've got a longer bit here, so we've got that distance and that distance. So this is going to be A. The difference between that is this bit here is sticking out the front. So it's going out towards that side of it. So that has to be 3. There it is there, the small bit. With the small gap up here, and this bottom bit is sticking out the front. So there we have A. This fella here is the same, except that bit is turning backwards. So it's all the same, except this bit is turning backwards, so that has to be here. And if that's that, then this is B. That's 12. Alright. Okay, 13. Alright, there we go. Right, 13. The 3D graphic shows a football as it strikes the back of a goal net. What's shown is the end view of the goal net and a football O. So the football in a position where it strikes the back of the net and rests on the ground. Show all constructions of the point of contact. So look, what are we talking? They want to basically take out everything, goals or whatever. They want the ball sitting inside there in the corner, touching up this line, touching up this line. Well, we know from solids in contact that if it has to touch this line and touch this line, how far will it be away from this line? How far will the centre of that circle be away from this line? It will be the radius. How far will the centre circle be away from that line? It will be the radius. So if I take the radius of that circle and do it perpendicular from the ground, I could draw a perpendicular line, but the goalpost is actually a perpendicular line, so I can just mark it off on that. And I'll draw that as a line. So that gives me the centre of every single circle. In fact, if the ball was rolling around the ground there, that's the centre of every centre. If I took a video of the ball rolling along the ground there, going along there like that, I could pause it anywhere and the centre is going to be somewhere along that line. Alright? After that, I don't want it sticking out here. What I wanted is touching off this line here. So if I want to touch it off that line there, I have to get the perpendicular distance of the radius out there as well. To draw the perpendicular distance, I have to draw a perpendicular line. So, okay, that's parallel to the line there like that, well at 90 degrees. That line is going to be 90 degrees there. So I'll draw any 90 degree line to it, and I'll draw the same distance out there, away from it. And then I'll draw a line parallel to the back of the net through that point. There we go. And then there's the centre of the. So that's all the circles that are going to touch off that line. That's all the centre of all the circles going to touch off that line. That point there is the circle that touches off the top and the bottom. There we go. And I'm done, am I? I'm not. Read the question. Show all constructions and points of contact. So the point of contact between a circle and a line is perpendicular to that line through the centre of the circle, there like that. So there is my point of contact here. The point of contact between the circle and line is perpendicular to that line through the centre of the circle, where it crosses through the circumference of the circle. That is my point of contact. There's parallel to the line, there's perpendicular to the line, there's the centre of the circle. Draw my line where it cuts through the edge of the circle, that gives me a point of contact. There would have been 3 marks anyway going for that, lads, to get points of contact. So if you hadn't read the question or decided you'd have done when you did circling there, you would have lost them. It was straightforward enough. So make sure they're perpendicular through the centre. Perpendicular through the centre. Alright. Next question, another freehand. So they want us to cast a shadow here. So the graphic shows 3 solids. The light is shining on the solid as shown by the direction of the arrow. The shadow cast by the first solid has been. Please excuse me. Draw a freehand sketch of the shadows cast by the other 2 solids. So the shadows cast by the other 2 solids. Let's see, a lot of interest. Right. So what are the shadows cast by the other 2 solids? So look, if I took the centre of that, there's the lines going out, look. That gives me some sort of an idea what's going on. See that line going in that direction? So that line is going in that direction. That kind of gives me an indication of where that shadow is going to be. So if I draw out them lines going in that direction, and we come across it, kind of a 90-degree angle, and draw that one out there. We're talking like out in that direction, it's getting cast out in that direction, alright? And if it's getting cast down in that direction there, well, it's the same for the top of that. There it is there. Draw it down there. The centre of the circle is going to be right, or the centre of the top of the cone, or the apex of the cone is going to be right over the centre of the circle. So I do that for the out in the direction I'm giving over here, and then down from the top. Well, that's going to be probably where that shadow was cast. If I join the edge of that, so I'll draw like a tangent to that ellipse. Sketch it now, I don't have to do any constructions. Going out there like that, and then the apex going back there like that. Something there like that. Right? Draw it in there. That's what we're talking there like that. And I shade it in. There's my shadow cast by the cone there. Alright, after that, we've got a sphere here. A little bit more difficult now, so we're going on at that angle. So I'll start looking at maybe, Jesus, what's going on here? So, you know, your line going down there in that direction. It's going down there in that direction. So, the sun hits it here, and the shadow is going to hit the ground along that line. That's the last bit of the sphere that the sun will hit there. So it's going to be out here somewhere. So look, probably going to have to just guess this one. So look, I'm going to say, I'll go here, maybe it hits the ground there. Try and imagine it, but probably that will be the top of it. Alright? And then this line going in that direction, no, it's going to be an ellipse, isn't it? It's going to be some sort of an ellipse. There's the line going in that direction, they're all going in that direction. So if I use that line, like that, something like that, oh, there's the line going there, maybe that's going to be the bottom of the ellipse. Alright? After that, what kind of shape will I make? So I'm going around with an ellipse like that. This is, you know, something like that. Something, you know, there's something like that, I would say. So as long as you draw an ellipse kind of within reason, as long as the back of the sphere and the front of the sphere are along them lines, you're not going to be too far off at all. So we're talking something like that, an ellipse. Maybe something like that. Alright, fill in what we need. Here. We're talking something like that, lads. Something along them lines. Alright? So just, you know, use the lines, so, you know, you can't just draw your hat line and go, oh, I'm not great at freehand sketching. Use the lines they're giving you that line, and they're giving you lines going that way. So use it, the apex is, you know, it's going to be along that line somewhere. Shadows cast down that direction. Same here. I'll just use what I have, you know. You have to kind of imagine that sphere, the shadow of it hitting the ground. What would it look like? It might even be a bit fatter or thinner than that. But as long as, you know, you follow some sort of rules, you get the marks for that, right? Okay? Alright, last one. Oh, I don't think you can see that though. Yeah, last one. Right, okay. So, the sale of fruit in a school canteen was recorded over a period of weeks. So we've got a line graph here, lads, which is good news because you don't have to colour it in. So the sale of fruit in a canteen was recorded over a period of a week. Sounds like an exciting job. The following are the results. Apples, 60 apples. So they went, I was going to say, so they like the apples. So that would indicate that height there's apples. So that indicates that that's 60. Bananas were 45. Well, that's a 45. So we've got 1, 2, 3 of a gap going down. So that must be 55, 50, 45. That would make sense there. So there's our 45 there. Alright. So that will indicate that each drop is 5 pieces of fruit. So 60, 55, 50, 40, 35, 25, 20, 15, 10, 5, 0. What have I done there? 60, 55, 50, 45, 40, 35, 30, 25, 20, 10, 5, 0. Right, so just to show you that that's what a mistake, obviously I did that on purpose to show you what a mistake looks like. I wouldn't have not been able to count. Right, so we've got 60 down to 45. Then the grapes are at 25, so there's 25 there. Kiwis are 20. Oranges are at 40, so there's 40 line going across at 40. And then pears are at 10, there we go. So we'll show our line graph, join all the points. So that's there, back up to this next point. And down there. Right, so that's what our line graph looks like. Right lads, 2017 questions. That's them all done. When you get whatever 5 you didn't do or whatever mistakes you made in the 10 you attempted, when you get them completed, please, for me. For the next, I'll put the details up in the group there.